Classes of Medicine. Welcome to another video in our endocrine physiology series. Today we will be looking at regulation of calcium. Right. So, what are the objectives of today's video? Today we're going to be looking at parathyroid hormone. We're going to be looking at how vitamin D works in all of this, and then we'll be looking at calcitonin. Right. So, regulation of calcium. Calcium is a very important ion in your body, right? Most of your calcium is trapped in your bones, right? Remember, bone is a calcified matrix, right? There's calcium and phosphate, right? So most of your calcium is in your bones, okay? And then the rest of the calcium, some of it is bound to albumin in the blood, some of it is free, some of it is intracellular. Anyways, calcium is a very important ion. That is the basis. So, how do we regulate our calcium? Okay. We achieve calcium regulation through the hormones parathyroid hormone and calcitonin, and also with the help of vitamin D. Let's start with parathyroid hormone. Okay, so over here you have your thyroid gland, right? We all know our thyroid gland, thyroid hormones and whatnot. So our thyroid gland, on the posterior side, on the posterior surface of your thyroid gland, you also have these small pea-like glands, right? These glands, they're known as what? They're known as parathyroid glands, right? Parathyroid glands. And as you've guessed, I'm sure you've already guessed with it. From these parathyroid glands, right, this is where you release your what? Your parathyroid hormone, okay? So, in your parathyroid glands, right, you have two types of cells. You have oxyfuels and you have chief cells, right? So, these chief cells, these are the cells which synthesize and secrete the parathyroid hormone, right? Now let's zoom in on a chief cell. Over here we have a chief cell, or what we think it looks like, alright? So, if you look closely to these, there are these vesicles inside our chief cell, right? These vesicles, they contain the hormone parathyroid hormone, right? Now, these vesicles are already inside our cells, they're already synthesized, right? But then they're not being secreted. Why? That is because of today's main actor, right? That is because of calcium, right? So in conditions of calcium, high levels of calcium, or when calcium is in its normal range, yes, in its normal range, so we have calcium over here inside the cell inhibiting the release of parathyroid hormone. So it is actually calcium which inhibits the release of the parathyroid hormone, right? When calcium is in its normal range, right? So what happens when calcium levels, when they decrease? What happens when they decrease, right? So when calcium levels decrease, this inhibitory intracellular pathway, right, is now disturbed, is now broken, right? We no longer have calcium inhibiting the release of what? Parathyroid hormone, right? So without calcium inhibiting the release of parathyroid hormone, what happens? Parathyroid hormone is released, right? So when parathyroid hormone is released, these vesicles, they are exocytosed outside, they go into the blood. This is a blood vessel, an artery or a vein. So they are released into the blood, right? So now we have parathyroid hormone in the blood, right? Parathyroid hormone. So now, how does parathyroid hormone regulate calcium? So parathyroid hormone's job is to increase the calcium levels, right? So how does it increase those calcium levels? It does that by acting on three main sites, right? First, we have the bone, right? Second, we have the kidneys. And lastly, it also acts in the GIT. It increases absorption of calcium from the GIT, right? So let's start with the bone, okay? Let's move on here. Let's focus on this diagram, right? So on this diagram, we're inside our bone, right? So the thing with bone is that bone is being continually made and broken down. So it's a continuous process of absorption and resorption of calcium, right? So in our bone, right, we have two types of cells. We have osteoblast and we have osteoclast, right? Osteoblast, they build up bone, and osteoclast, they break down the bone, right? So what parathyroid hormone does is that it comes over inside the bone, comes over to this cell over here. This is an osteoblast, right? It's an osteoblast. So on the cell membrane of an osteoblast, we have these receptors, right? These certain receptors on the cell membrane. What parathyroid hormone does is that it comes and binds to these receptors. Over here, it binds to these receptors. and it induces what? An intracellular transductory pathway, right? CAMP, we know the transductory pathways. It is a story that has been sung over and over again, right? So what happens is that the transductory pathway, it takes place, and it results in the synthesis of a protein, right? A certain protein in the osteoblast, right? This protein is known as a rank ligand, right? Over here we have our rank ligand, okay? It's a rank protein, right? So that protein is then released from the osteoblast, right? This is released from the osteoblast. It comes over and binds to another membrane receptor on the osteoclast, okay? Over here we have a receptor on the osteoclast. So now our rank ligand, this rank ligand, it comes over and now it binds on this surface receptor of our osteoclast. Just binds over here on the osteoclast. Now, what happens when it binds to the receptor, right? It induces another intracellular transductory pathway, right? Now, this transductory pathway in our osteoclast, right? The transductory pathway, it leads to the synthesis of certain proteins and certain enzymes, right? These are very special guys. They are known as cathepsin K. Cathepsin K, this is our first member. And the other one is acid phosphatase, right? Acid phosphatase. And you can already tell from the name, acid phosphatase is an acid which is going to be what? Breaking down what the phosphate inside our bones, right? So cathepsin K and acid phosphatase, they now break down our calcium and our phosphate, which is inside our bones, right? Now these guys, they are released, and once they are released from the bone, they go where? They go into the blood, right? So they go into the blood. So now we now have calcium ions in our blood, right? So that is the first mechanism in which parathyroid increases calcium levels. The second one, right? We say parathyroid hormone acts on the kidneys, right? Acts within the kidneys, right? So what happens is, let's move on to this third diagram. What happens is, over here you have a general structure of your nephron, right? These are your afferent arteries. These are your efferent arteries. They take blood away, and the afferent ones, they bring blood towards what? Towards this structure, right? So, over here you have your proximal convoluted tubules. You have the loop of Henle. This is the loop of Henle. And over here you have your distal convoluted tubules, right? And over here you have your collecting ducts, right? So we want to focus on a certain part of this nephron. We want to focus on the distal convoluted tubule, this part over here. Let me change my marker. We want to focus on this part over here, right? So what we did is that we just focused on this part. We zoomed in on this part, right? So over here you have your lumen. This is the lumen of your distal convoluted tubule. It contains what? The filtrate. It contains the filtrate. And this is where our calcium is, right? We have calcium flowing inside the lumen over here. So what parathyroid hormone does, right, is that it binds to an extracellular receptor, right? It's a membrane receptor on the cells of your convoluted tube. It binds on this membrane receptor. And again, like we've said over and over again, right, it induces an intracellular transductory pathway, right? Now, intracellular transductory pathway, it activates certain transcription factors. Those transcription factors, they are transcribed to mRNA, then mRNA protein synthesis. We have the synthesis of certain proteins, right? Synthesis of certain calcium channels, right? There are calcium channels which are synthesized inside our cells. These calcium channels now move to this part over here, and then they span the membrane like so. Span the membrane like so. Now what these calcium ions do is that they basically provide a doorway, right, for all calcium ions to flow through. So now we have calcium moving from the lumen into the cells, right? We have calcium moving from the lumen into the cells, okay? So now once calcium is inside the cells, right, what it does, right, we have another actor, we have another guy who plays a big role, right? You know this guy, you're familiar with him. His name is the sodium potassium pump, right? So we have our sodium potassium pump over here on our membrane, right? What does the sodium potassium pump? What does it do? It pumps out what? It pumps out 3 sodiums and pumps what? Inside. It pumps 2 potassium inside. So 3 sodiums outside and 2 potassium inside, right? So what the pump does is that it keeps on pumping sodium ions, and sodium ions, they tend to accumulate outside like so, forming a steep diffusion gradient, right? So now we have more sodium outside and less sodium inside, right? So what sodium does is that now it wants to get back inside the cell, right? And it's going to accomplish that through another channel. This channel is actually an antiporter, right? It is an antiporter in the sense that it allows sodium to diffuse back inside the cell, but at the same time, right, it also allows calcium, right? We have our calcium over here. It allows calcium to diffuse outside the cell, right? It is an antiporter, right? So when calcium diffuses outside of the cell, where does it go, right? It goes to the same destination, goes into the blood, right? So this is how parathyroid hormone increases calcium ions by acting on the kidneys, right? It reduces the amount of calcium being secreted in urine, right? It increases reabsorption of calcium back into the body, right? Okay, so that is the second mechanism over here. First was bone, remember? The second is the kidney, right? Now the third one is sort of an indirect way parathyroid hormone is acting to increase calcium. So what happens is that it acts through vitamin D, right? So in your skin, right? You have this compound called 7-dehydrocholesterol. 7-dehydrocholesterol, right? Now this 7-dehydrocholesterol, upon stimulation from UV radiation, right, ultraviolet radiation, the sun, it then is now converted to cholecalciferol. Cholecalciferol, right? Okay. Now this cholecalciferol now migrates to the liver, right? Inside your home. It migrates to the liver, okay? Once it is in the liver, right, we have a special enzyme, right? This enzyme is called 25-hydroxylase. 25-hydroxylase. And remember, this guy is in the liver, right? And from his name, you can already tell that he's adding a hydroxyl group on the 25th carbon, right? On the 25th carbon of what? Of our cholecalciferol, right? So if we add a hydroxyl group on the 25th carbon of cholecalciferol, what does it become? It becomes 25-hydrocholecalciferol, right? Cholecalciferol, right? This is in the liver, okay? So once it becomes 25-hydrocholecalciferol, it again migrates to your kidneys. Remember the kidneys. It goes to your kidneys. And in the kidneys, right? In the kidneys, there is another special enzyme, right? This enzyme is called 1-alpha-hydroxylase. Hydroxylase. So what 1-alpha-hydroxylase does is that, as you can tell from its name, it adds a hydroxyl group on the first carbon of our 25-hydroxycholesterol, right? If we add the hydroxyl group on 25-hydroxycholecalciferol, what does it become? It now becomes 1,25-dihydroxy, right? Because now we have two hydroxyl groups, right? Dihydroxycholecalciferol, right? This 25-dihydroxycholecalciferol can also be known as calcitriol, or vitamin G. You can call it vitamin D, right? So, where does parathyroid hormone come into play in all this, right? Remember the enzyme in our kidney, 1-alpha-hydroxylase, right? This enzyme is actually activated by parathyroid hormone. Parathyroid hormone, it comes and activates 1-alpha-hydroxylase, our enzyme that added the hydroxyl group to the first carbon of what? Of 25-hydrocholecalciferol, right? Okay, 25-hydrocholecalciferol. So, now that we have our 125-dihydrocholecalciferol, what happens next? What happens next? Remember, the goal is we're trying to increase blood calcium levels, right? So what happens with 25-dihydroxycholecalciferol is that it goes to the GIT, right? Now the cells lining your GIT, they are known as enterocytes, right? Enterocytes. So what happens is that this vitamin D, it has steroid hormone properties, okay? So what it does is that it comes and enters our cell and acts on intracellular receptors, right? We have intracellular receptors over here inside our cell. Remember, we said it has steroid hormone-like characteristics, so it is able to enter, through the cell membrane. Okay. So once it binds to these intracellular receptors over here, once it binds to the intracellular receptors, it again induces another intracellular transductory pathway. Remember these transductory pathways. Okay. So this transductory pathway activates certain transcription factors, and the transcription factors, mRNA, protein synthesis, right? We have synthesis of a certain protein, right? We synthesize calcium channels. So these calcium channels, they now align your GIT. So over here you have your GIT, and you have a calcium inside your gut. So now that we have a doorway, we have a channel in which calcium could go through, right? We have more absorption of that calcium, right? Into what? Into our bodies, into our blood. Okay. So that is the third way in which parathyroid hormone increases the blood calcium levels. Okay. So let's recap a little bit. So the first one we said we have the bone, right? In the bone, the exon osteoblasts, right? The osteoblasts, they synthesize a protein known as the rank protein, right? This rank protein, it now goes and binds to an extracellular receptor or on an osteoclast, right? This rank ligand over here, it binds to this receptor on the osteoclast, right? Intracellular transductory pathway, protein synthesizes certain enzymes. We have cathepsin K and acid phosphatase. Please remember these two guys, cathepsin K and acid phosphatase. These guys are the ones which break down what? Which break down our bone, right? To carry out the process of bone resorption, and now our calcium goes back into the blood, right? Now the second pathway was in the kidneys, right? In the kidneys, where parathyroid hormone was bound to a receptor, right? Intracellular pathway, calcium channel secretion, we synthesize these calcium channels, right? And allowed more calcium to flow from the lumen into our kidney cells over here. And then we have sodium, potassium pump, right? High concentration of sodium outside, low concentration of sodium inside, right? Sodium was flowing back into the cell. At the same time, calcium was flowing out of the cell, right? This is a form of secondary active transport, okay? And the third one was when parathyroid activated the enzyme in the kidney, 1-alpha hydroxylase, right? In the formation of what? Of vitamin D. Vitamin D, which later went to your GIT and caused the synthesis of certain calcium channels and allowed more calcium to flow through your gut. Okay, so these are the ways in which calcium levels in your blood are increased, right? So now that you have high levels of calcium in your blood, right? Now our calcium levels are now elevated. Remember, what did we say calcium do when the video was starting? We said calcium, it did something in these chief cells, the chief cells of the parathyroid gland, right? It inhibited the release of what? Of the parathyroid hormone, right? So when our calcium levels are now elevated, right? We now have calcium again inhibiting the release of parathyroid hormone. So our parathyroid hormone levels in our blood, they now decrease. Right? We have now low parathyroid hormone levels in the blood, and all of this stops. Right? It stops. Okay. So that was the mechanism in which we increase calcium, right? But how do we decrease calcium? Okay. How do we lower the blood calcium levels? Okay. So in your thyroid gland, remember, in your thyroid gland over here, we have certain cells, again, these cells are known as parafollicular cells, remember, parafollicular cells. Now these parafollicular cells, they're the ones which secrete calcitonin. Now calcitonin's job is basically to what? To reduce the levels of calcium. So it is stimulated by what? By high levels of what? By calcium. So calcitonin gets into the blood, it inhibits what? The processes which increase our calcium concentration, right? So thank you guys, that has been regulation of calcium, right? So we'll catch you on another video and we'll continue our endocrine physiology series. This is your Dr. Ben saying goodbye.